Good evening, everyone. Today is day 29 of Math 133, which means it is the last day before the final exam. So we're going to wrap up the sample final and answer any questions you have. So I believe you guys left off on page 615, 615 of the sample final exam, so page 11. So we're going to work on that tonight. Um, Tomorrow, Cindy and Elaine are going to be covering any questions that you have, as well as making sure you have your exam notes packet and you got your 8.5 by 11 papers and you got everything ready to go for the final. Okay. Um, and then the final exam. So you could have possibly taken it today at the testing center, but you can take it at the testing center tomorrow, Thursday, or Friday. If you take it at the testing center, remember to bring your picture ID. Okay, that's important. If you're taking the final exam with me on Zoom, we will be starting on Thursday in the morning at 9 a.m. If you're taking it in the evening on Zoom on Thursday, we are starting at 6 p.m., 6 o'clock until 9 o'clock. So make sure that you join at 6 so that you get the full time to work on the final. Okay. Um, all right. So let's go to, so if you click on the sample final exam in Canvas, there's a link that when you click on that, it'll take you to the worksheets or the data links for all of our worksheets. Way down at the bottom, there is a link for StatCrunch for the sample final exam, and I'll drop this in the chat for you. There you go. But we're going to start on page 615. Okay. All right. So in 2022, the Pew Research Center surveyed groups about their support of same-sex marriage. They found that out of 2,800 male adults, 1,600 said they support same-sex marriage. They also found that out of 2,100 random U.S. female adults, 1,300 said they support same-sex marriage. Find the following. Okay, so the sample size for men was 2807. X is the number that agreed, 628. So P hat is X over N. So somebody put that in the calculator for me. 1628 divided by 2807. Yep. Thank you, Caleb. 0.58. Okay. Then I need Q hat for men. So 1 minus that. So 0.42. All right. For female, it was 2191 and 1380. So 1380 divided by 2191. 0.63. All right. And 1 minus that. All right. 0.37. All right. Verify the conditions necessary to construct a confidence interval of the difference in the proportions of U.S. male and female adults who support same-sex marriage. Okay, so we need to verify that we have the central limit theorem satisfied. So in this case, we have two samples. So we need to check that they're both random. We need to check that they are independent or dependent. Okay, independent And we also need to make sure that they are both independent of the population. Okay. And lastly, we need to check and make sure that they are normal. Okay. All right. So, random. Yes, both of them are random. We got that, and they gave us that. So, independent. These two, male and female, are two different groups measured once, right? So two different groups. There's no overlap. We can't have someone who is in, there's not going to be anyone who's in both groups. Okay. Independent of the population, we need to check 20 N is less than capital N, and we need to do that for both male and female. So for male, it's 20 times 2807. Can somebody do 20 times 2807 in the calculator? Thank you, Mike. Thank you, Ryan. 56,140. And that is less than all US males. So we're good there. But I also need to check that for females. And of course, I'm running out of room. I never give you enough room on these worksheets. Sometimes they'll ask you like one question and give you this giant space, and then others they ask a bunch of different things and you got no space. So 20 times 2191, please. 20 times 2191. Maya says that's 43,820. And that is less than the number of all US females. So we are good on both of those. So we have a yes. Okay. Lastly, for normal, we need to check NPQ is bigger than 10. Now, if we were doing hypothesis testing, we would compare P0 and Q0. We're not. We're looking at confidence intervals. So we're going to use P hat and Q hat because there is no P0 or Q0 here. For men, this is 2807 times 0.58 times 0.42. You need to know what that gives me. 683.79, which is bigger than 10. For females, it is 2191 times 0.63 times 0.37. The rank 5, 10.72, which is also bigger than 10. So yes. All right. Part C. Construct a 96% confidence interval of the difference in the proportions of US male and female adults who support same-sex marriage. So what we're trying to see here is we're trying to see if men and women answer this question differently. Okay, does a different number of people's or does a different proportion of them support same-sex marriage, or do they both support it equally? Right. So that's what this difference is. So, what page do I need to look at when we're talking about confidence intervals for this? So I'm looking through my exam notes packet because we're going to do this in StatCrunch, right? So if you already know the StatCrunch buttons, like if you have that memorized, you can just tell me what StatCrunch buttons to push. But if you don't, that's okay. Just tell me what page. You don't have to memorize the StatCrunch buttons. It's all in the exam notes packet. It's just a matter of finding what we're looking for. So Crystal says page 260. Yes. Page 259 and page 260 are the two pages for confidence intervals. And since we have two different populations or two different samples, we are looking at page 260. So there's three of them there. There's proportions, matched pairs for means, and independent means. So we're looking at proportions, so we're doing the one at the top. Okay. So that would be stat, proportion stats, to sample with summary. Now, I've said before that confidence intervals and hypothesis testing are very closely related. Okay, they both rely on the central limit theorem, and actually, this is the exact same StatCrunch path that you would use for hypothesis testing. It's just when you select what you're doing, there's a blue button for are you doing confidence intervals or are you doing hypothesis testing? So we want stat proportion stats to sample with summary. And I have for men, it was 1628 out of 2807. 1380 out of 2191. And like I said a second ago, so hypothesis testing and confidence intervals, it's actually the same StatCrunch path. So we in this case are looking at confidence intervals, and we're looking at 96%. And we'll hit compute, and that'll give us our upper limit and our lower limit. Lower limit is negative 0.0784, and the upper limit is negative 0.0213. Make sure you pay attention to whether it's positive or negative. Okay, in this case, they're both negative. Okay. Does the interval support that there is a significant difference in the proportions of men and women who support same-sex marriage in the US? So, like I said, hypothesis testing and confidence intervals are very similar to each other. And actually, what this question is asking us to do a hypothesis test with our confidence interval. Really, that's what it is. Okay. So to answer this question depends on whether zero is in the interval. So if the lower limit is negative and the upper limit is positive, then zero is contained in your interval. If they're both positive or they're both negative, then zero is not contained in the interval, which is what we have here. So zero is not contained in the interval. And so yes, that means that there is a significant difference. So in this case, women support same-sex marriage more. They're more supportive. Okay. So there is a difference in if they're male or female, it's going to affect how they answer this question. Okay. Um, okay. So like I said, if you did hypothesis testing on this, right, instead of a 96%, you'd be looking at a 4% alpha, right? And so if we were looking at this and we did hypothesis testing, you get a p-value of 0.0004, which is smaller than 0.04. So you would reject the null. And so the alternative hypothesis would be that there is a significant difference. There is sufficient evidence to support the claim that the men and women answer this question differently, right? So, okay. You want to re-examine the difference in support for same-sex marriage between men and women, because that was back in 2022. So we want to check if it's what it is now. Using the above prior estimates, how many men and women would you need to survey in order to estimate the difference with 90% confidence, 3% margin of error? So we need the formula, substitution, and our result. Okay. All right, so what page do I look for this stuff? So you've got your flow chart, right? And the flow chart tells you, okay, there's three different things that we've talked about. We've talked about confidence intervals, we've talked about hypothesis testing, we've talked about sample sizes. In this case, yes, we're looking at sample sizes. All of the sample size stuff, Mike's got it. It's page 261, and it depends on whether you're looking at single. We are looking at a double, and so we're going to be looking at this one because we have a prior estimate. So I'm going to start by writing this whole formula out. So it's n equals n1. You can write nm for male and then nf for female if you want. Either way is fine. Or you can write 1 and 2. I don't care. So p hat for males, q hat for males, plus p hat for females. And we need Zelp over 2, error squared. And now we're just going to substitute in, plug in all of the numbers we have. So for men, it was 0.58 times 0.42 plus 0.63 times 0.37. Our error was 3%. Now for the z value, I need a 90% confidence. So actually I need to go to StatCrunch for that. So what page would I look at to calculate my Z value? What StatCrunch buttons do I need to hit for that? So you can either tell me the page or you can tell me the StatCrunch button. So Mike says it's on page 258. Yes. Page 258 says we do stat calculator normal to find Z alpha over 2. Okay. So maybe it would be helpful on page 261 here. So to calculate Z alpha over 2, I need to go to page 258. Okay. Just as a reminder for myself, because we got to find that Z value. So it was stat calculators normal. And we do between, and I need 90% confidence. So my Z value is 1.6449. All right. And now that I have this, I'm just going to plug all of that into my calculator and see what we get. Six three nine 0.7. Close my parenthesis, open another 1.6. And square it. 19. Oh, no, that isn't great. Oh, yeah. I screwed that up. There we go. 1433.1. And we round that up. Yes. 1434 and 1434. Wait a minute. All right. So let's go to page 616. Municipal coach wants to improve the max vertical jump in inches of their players. They design a training program for 1 month, measure the max vertical jump of their players at the end and the start of that month. Results are in the table. Okay. So we need these differences. Now, these are already listed in that StatCrunch link that I provided to you, not this one. Here. Okay. Got my players, end and start. And you would measure the start first, but I want to measure the difference between these. So I want to do this one minus this one. So 24 minus 23. This player is now able to jump 1 inch higher, right? Um, okay, so uh, the there's a button in StatCrunch that actually will calculate these differences for you. So I'm going to skip ahead a little bit. First of all, when we do this hypothesis testing, uh, I need to know what page I'm going to find the StatCrunch buttons for this hypothesis testing. Hypothesis testing for, let's see, are we doing means or proportions? Are we doing matched pairs, independent? What are we doing here? What page uh, do I need to go to? Page 265. Isaiah is got it. Yep. Matched pairs. So we're looking at means, the average height that they jump. Okay. Page 265. And that says we do T stats paired on page 265. So stat T stats paired, and we're going to select our end and our start. Okay. There's a button right here where it says differences. So we're going to select that. And that is going to give us the differences. So we need to write those down on page 616. So 1, 1, 2, minus 1, right? Okay. All right. Uh, which of my minus ones is it right? Number 4. So uh, 18 minus 19 should give you minus 1. So you want to make sure you're subtracting end minus start. Um, because we're trying to see if at the end, yeah, so um we're trying to see if the training program improved their maximum jump. So this guy at the start, he was able to jump 23 inches high, and then this one, after he did the program, he's now able to jump 1 inch higher, which is great. This one 1 inch, this one 2 inch. This guy at the start, he was able to do 19, and somehow he now can only do 18. So maybe he got fat, and now he can't jump as high. So I don't want to write that as 1. I want to write that as minus 1. So, and then this one, this guy lost 2 inches, but everybody else went up. So yeah. So, okay. The above here, is this an example of independent, dependent, qualitative, or quantitative? It is dependent, okay, because it's the same group of people measured twice, okay, once before the program and once after, okay. Is it qualitative or quantitative? Measuring heights, which is how high you can jump, or that is measured in uh, yep, numbers, right? And it's not asking you if it's continuous or not, but you can jump 1/2 inch higher, so uh, it would be continuous if they were asking us if it was continuous or discrete. Find the following. So, the n for the distances. So this is d right here. This is the difference. Okay. Um, yeah, they rounded here, so yeah. The n is how many you have. So that would be 10. Uh, what's the degrees of freedom here? Yep, I think it says 9. It's one less. That's correct. D bar, which would be X bar, that's the average. Now, when you do the StatCrunch, it'll actually give the average to you. So it's 1.2000 or just 1.2. And the standard error, they also give you that 0.4899, but they don't give you the standard deviation. So that's annoying. So we're going to need to compute that. So to get the standard deviation, and it'll give us the mean as well, page 254, method 1 will let you get the standard deviation. So we need to do that real quick. Summary stats columns. We'll select our differences. So I've already got the mean. I need the standard deviation. Now, is this a population or is this a sample? This is the population. This is all of his players. He's got 10 people on a basketball team. That's a normal number. So I need the unadjusted standard deviation, okay? Because that's going to give me my population standard deviation. So if we hit compute, my unadjusted standard deviation is 1.4697. And you can see I got the same mean, 1.2. So, okay. All right. Coach claims that the training program helped increase the max vertical jumps of players. Okay. On average, right? Didn't help this guy. But test this using a hypothesis test. So the null hypothesis would be that the mean of the differences, right? Not the mean of their start and end, but the mean of the differences. If your start and end is 0, then that means you didn't get better or worse. Okay. The alternative is that the mean of the differences increased, right? You don't. So yeah. So then our alpha 0.05. So page 265 says we do stat t-stats paired. So I already did it. Stat t-stats paired, but I didn't do it quite correctly. I did not equal. So I'm gonna go to options and edit that, or you can redo it. You can do stat t-stats paired and start, and I need this to be a greater than. Oh, whoops, now I got more differences. That's fine. Okay, I need my t-stat though for step 3, which is in this case 2.449, and my p-value 0.018. Okay. Here's T0 right here. This is my shaded area. Alpha is 0.05. Is this bigger or less than? Is it greater than or less than here? This one's less than. So do we reject or not? Reject or not reject? We do reject, yes. Check the null hypothesis. So that means that there is sufficient evidence. Support the coach's claim. What was he claiming? That program Proved the max vertical jump of his players on average. Okay. Okay. Page 617. A physiologist believes that usage rates for fitness trackers are lower for men than women. That's probably true. My sample size of one. I don't use one, but my wife does. They gather a random sample of 450 men. 18% of them use a fitness tracker. 388 for women, find 25% of them use a fitness tracker. Would this be independent or dependent? Qualitative or quantitative? It's independent and qualitative or quantitative. So in general, when we're looking at probabilities, it's qualitative. Okay, you can see that we're looking at p hat here. Um, so if I so think about what the answer to the question is. So if I ask my players how high they can jump, what's their max vertical height, their answer is going to be a number. I can jump 24 inches. Okay. If I ask a man or a woman, do you use a fitness tracker? Their answer is not going to be a number. Their answer is going to be yes or no. So it's going to be qualitative, independent qualitative. Okay. In general, not always, but in general, probability is looking at qualitative and it's saying what percent are yes, and the percent is a number, sure, but the answer to the question is qualitative. All right, so let's fill in this information. Q hat. So I need 1 minus 18%, please. Making that 82. And for x is n times p hat. So I need 450 times 0.18. And I need to round that, but it's actually already a whole number. So x and n are always going to be whole numbers. So uh, somehow that ended up a whole number though. For female, it's 388.25. So 1 minus 25% should be 75%. Yep, thank you, Ryan. 75. And I need n times p hat for females. I think it says 97. All right, good. Is there enough evidence to support the physiologist's claim at the 1% level of significance using a hypothesis test? Okay, so null hypothesis is that they're the same. The p-value for men and women is the same. They both use fitness trackers the same level, the same just as often. Uh, for the alternative hypothesis, they're claiming that it's lower for men, so it's less than, right? Alpha 0.01. All right. To get my z value here and my p value, I need to do stat crunch. what page am I going to find the StatCrunch buttons for this? Hypothesis test. Page 264, yes. And page 264 says it is stat proportion stats to sample with summary, which is the same StatCrunch as proportions for confidence intervals. Stat proportion stats to sample with summary. And I have 81 out of 450, 97 out of 388. I want to do hypothesis testing. So if P1 minus P2 equals 0, then that means they're the same number, right? So so the null hypothesis is that probabilities are equal. An alternative, I'm looking for lower, less than. So I will hit compute and I get my Z value, which is negative 2.4704, and my p-value 0.0067. Yes. Okay, there's my Z value right there. So now I'm going to compare my p-values and my alpha 0067, 0.01. Is this p-value less than alpha or greater than alpha? It is less than. So that means that we reject no. Yep, you got it, Jaden. All right. That means there is sufficient evidence. Support the claim that men use fitness trackers less often than okay. And our last page is page 618, number 18. A researcher believes that students in the Eastern US and Western US have different amounts of college debt at graduation on average. Gather a random sample of Eastern and Western states, find the average college debt in dollars for students that graduate from four-year institutions in those states. Results. So they did the StatCrunch for us. Is this a left tail, right tail, or two-tail test? Mm-hmm. Yep, it is two-tailed because we're looking at a not equal. Good. How many eastern states were sampled? Mm-hmm. What was the average amount of college debt for students in the West? So the mean right here, 25,394, $25,000, right? I wonder if is Michigan counted as Michigan's in the Midwest, right? Normally when I think of eastern states, I think of like Harvard and Yale. Those are expensive. Those are in the East. So probably not counted in this. Explain why this is an example of independent sampling. What do you guys think? Why is this independent? Yeah, this is two different groups measured once. So are they different groups? Yeah, there's no overlap here, right? Two different groups. There's no state that's both Eastern and Western at the same time, right? Two groups measured once. Good. Use the computer output to conduct the hypothesis test at a 4% level of significance. So I'm going to skip a few steps because, there's step one. Step two is here's my alpha. Step three is here's my Z stat. So I'm going to start at step four, where we write out our p-value. And in this case, the p-value is 0.013. And this is a two-tailed test, so I'm filling in both of these areas, right? So this is negative t0 and positive t0, right? But my total p-value is 0.013. P-value in this case, 0.013. Alpha 0.04. Less than or greater than. This is less, so we reject. Got three rejects in a row so far. All right. That means there is sufficient evidence to support the claim that uh, students in Eastern and Western have different amounts. So, uh, Eastern and Western, uh, yeah, different amounts of college debt. Average. Okay, so I don't know what that says about Midwest, but East Coast is expensive. I could have told you that. I used to live out there, so. All right. And with that, that is the end of the sample final exam, which means that's also the end of our worksheets together. So that's the last thing I have for you um, before the final. So yeah, I hope that you enjoyed statistics and thanks for being a good class. If you have questions, I'm more than happy to answer them. Otherwise, yeah, if you're taking it at the testing center, I won't see you. And so, good luck on the final. Yeah, so Jalen, yeah, you can turn in the sample final today, or tomorrow or Friday. Friday is the last chance to turn it in. But yes, we have finished the sample final. There's nothing left on it. Thanks, everyone.
Hey Joe, I just want to thank you for a good class. Like I actually
Oh
learned a
yeah,
lot and it was fun.
I
Well,
try to make it
it's a
fun.
personal opinion. I thought it was fun. I know some other people were
Yeah.
like, "No way."
Well, I mean, when I was in college, I hated statistics, and I was like, why? Because I love math, and I finally figured out it's because of my teachers. And so whenever I teach statistics, I do try very hard to make it fun. So glad you enjoyed it. Glad you learned stuff. So
I did, and like I was telling Cindy, like I just found out I can't go to school anymore after this
I heard
class.
about, yeah, I'm sorry to hear that. Yeah,
Yeah,
that's rough.
it doesn't mean I'm done forever. It just means I have to
Yeah.
find another way.
Yeah. Well, you've been doing great in the class, Mike, so I hope you do. So good luck.
No, thanks.
Enjoy your summer. Yep.
I'll be working, but you know, that's how
Me
it
too.
goes.
It does. All right.
But thank you and have
Bye.
a good night.
You too.